Thank you, James. And thank all of you who are here in person and those that have joined online. So BluGlass is, as James mentioned, a pure play gallium nitride laser diode company. And what we mean by pure play is that's what we do. We do laser diodes, and I'll talk about our competition. We're one of a handful of global companies that can do what we do worldwide. And all of the others are part of large conglomerates. So that's why we're a pure play in laser diodes. We don't have to, we're not subject to the whim of larger companies. The GaN diodes, they're an emerging technology. And this technology is doing two things. It's consuming existing markets and it's creating new ones. And the reason is it has performance that is a quantum leap above the competition, which are traditional IR lasers. We talk about wavelengths. For you, the wavelengths that we are doing are simply just different colors. And we have, excuse me, in the market, I get some water when you get a chance. Violet is like 405, 420, up to blue. And that's where our core development has been and where our core products that we've introduced. We've already extended that up to aquamarine and down to the ultraviolet. Ultraviolet is light that we cannot see. So this is the visible spectrum, and we're moving up toward green. All of these lasers that we are generating can go into applications that are in the fields of industrial defense, scientific, biotech, and display. So the market overview, as James was saying, is $2.5 billion projected for 2025. Each one of these, and you'll recognize these global trends that are happening, Industrial 4.0, quantum, metaverse, the biotech, defense, electric vehicles. If we could put a laser into any one of those markets, it would thrill us. Our lasers play in all of these markets. We are supporting things from 3D printing, materials processing, artificial intelligence, the quantum computing and quantum sensing. Very exciting. We have things over here in the viral and bacterial mitigation and all up through the spectrum of these huge global trends. And again, that's spread across these markets and these verticals. The key takeaway from this slide is in the $2.5 billion with the products that we were introducing and in our near-term roadmap, our share with those products comes out to about $735 million, broken into the verticals like this. And you can see the different applications from the previous slide in each one of these verticals, and then some of the key customers that have engaged on those different areas. This is another look at the key players in the industry. And you'll notice some very household names, and some you probably don't recognize, but you've got Google and Panasonic, Samsung, LG, and they're more than just a display, but we're putting in general where they play. There's some that you probably don't recognize, like maybe IPG, Trump, Teradiode, Enlight. Those are huge laser companies. And those laser companies, you say, why would the laser company buy from lasers? Because they don't do what we do. So they want our lasers to help them do what they do. And then some of the recent stuff, as you know, the Department of Defense and ME Commons has been very exciting for us. So this is, with only a handful of companies, this is a constrained market. And it's constrained for a few key reasons. But it's largely because our competitors in part of the conglomerates are very focused on LEDs. LEDs, as you know, it's a very high volume, low ASP or low average selling price. And it takes a lot of commitment to be a high volume, low price competitor. And basically you end up being low mix. And the laser industry wants things easier to use than they could just get from those customers. And oftentimes they want some specialized wavelengths, especially when you're looking at markets like quantum markets. So what we provide is we have manufacturing flexibility. We have a team that's capable and willing. We've got dedicated equipment and so forth to be a GaN laser diode supplier. And our offering is differentiated. And it's differentiating because we're the only one that stands out in a company like this. There's not another one that we know in the world like us. And so what we're saying is we're providing light that's easier for our customers to use. When it's easier to use, it means basically for them less post-purchase integration costs. And so they're willing to pay us more, higher ASP. So we're more of a lower mix, or a higher mix, excuse me, lower volume model. So why blue? Or why visible? And I want to start by, a lot of this information isn't new. This goes back to like the 60s with NASA, but basically the absorption of laser light is how it processes materials. And you can see on here from steel to gold, very common metals that are out there in industry. You can see we're anywhere from 1.5 to 66 times the absorption. I'd like to jump in at copper because with the electric vehicles and the cell phone markets and all those things, there's a lot of work that needs to be done in copper, and we're 13 times the absorption from the traditional IR laser. So if you think about, if you had to do a job with a, I'll say 1.3 kilowatt laser, because it makes the math easy, it would only require a 100 watt visible laser. And so what happens is when you're processing with the 1.3 kilowatt laser, when the weld starts to happen, the material quality changes, and all of a sudden you get more absorption. It starts to splatter, and the splattering creates weak welds, and it also is a yield problem because if it splatters on other places, like on a PC board or something, you could cause shorts. So we can do cleaner, faster welding, and when you come to like 3D printing, what the higher absorption means is you could do thicker layers more quickly, so you could do bigger parts. But then when you come to the wavelength, remember I was talking about over here we had green, and the infrared would be a really wide wavelength, and when you come over the other side of the spectrum, our visible light is a small wavelength. And basically you could focus the light proportional to the wavelength. And so shorter wavelength, smaller spot size, which means cleaner, more precise manufacturing. And I want to tell a quick story. Talking to a customer and potential partner a few weeks ago, we don't have tin up here, but tin is very important in the industry, especially in PCB processing. When you're making the boards that go inside of computers, phones, cars, everywhere, they're everywhere. You have three key processes. You have tin soldering. You have marking of the boards. You have to put numbering and sequences where they know how to put the components, and you have what's called deboarding, because they make the PC boards on very large panels, and then the deboarding is cutting them into the small boards that are used. The customer said they have to use 3 different IR lasers for those 3 different processes, but with the visible, he could use 1/3 of the power, go 3 times as fast, and do all 3 processes with 1 laser. So that's the type of thing that's giving the quantum leap in performance for this blue stuff. And then there's another one, if that's not enough. It also interacts with organic materials quite differently, and also quantum materials. So visible lights interacts with viruses, interacts with bacteria, so you could do mitigation of problems there. That's a very exciting, and it's going to be a growing market. As many of you probably know that, for instance, antibiotics aren't what they used to be against the changing bacteria. So there's more interest in having light therapy. All right, so we mentioned Emmy Commons, so we're excited about this. This is a big deal. So $2 billion have been allocated. Sometimes they call it earmarked over five years. Of that, 238 million would come out in the fiscal year 23 budget. That budget is for the fiscal year 24, which just began in October. We are a member of one of the 8 hubs that were awarded, and our members, there's 460 members across all those hubs. Our hub has 1 leader and 7 members. So we have the lowest membership, and we have among the highest. We had just under 40 million US to our first year for this hub. So we're very excited. We're in there with, Coherent was one of the big laser companies in there, but they don't do the visible. They're also doing a lot of electronics, and GE, you recognize these names. So it's a good group of people to be part of the consortium with. And the whole idea is the US government wants to have the capability for itself and its allies to have these products available from concept, so they call it the lab, the universities, all the way to fab, which is the industrial partners. And so they want to have an avenue, and they call it a dual use. What they'd like to have is make sure that we can involve our customers in industry so they always have the technology available when they need a new product as well. Because sometimes the government volumes are up and down and sporadic. So they want to have it available commercially so they always they have access to it. So, there may be a little bit of worry, how does this impact where you're going? Do you have to now do what the US government wants you to do? Well, it's very well aligned. There's a lot of bullets on here, so I just want to give you the highlights. Basically, we have a roadmap. We shared what our roadmap is. We actually shared some of our DFB data, the distributed feedback that we've reported to the market about, and they loved it. And they said, we want you to do that. So there may be also worry about, how is this going to impact the grant and so forth. Our first blush that we understand is there's several buckets. We do development in Australia, and there's ancillary processes that are required to make sure that development gets to, because we can't do those in Australia. We have to continue that in the United States. That's going to continue. Then there's other things like production that's not part of that. And then there's things that we want to do, and I'll talk more about the roadmap, about the capability and functionalities we want to begin in to move up the value chain. And so those things can be covered by other developments that aren't part of the grant. We've talked quite a bit about single mode and multi-mode, and we also talked about DFBs. Really quickly, just to give you an idea, a multi-mode laser is basically wider on the chip, and what that does is it has multiple what's called spatial modes. And when you squeeze it down, you get sort of one narrower mode. Just to think about it from a standpoint of something maybe a little more common. Think of a multi-mode similar to an industrial saw, something that could cut through stuff. In the laser market, it would be processing big pieces of steel or beams and so forth. So very, very high. This is more precision, more like a surgeon's scalpel. And then when we do the DFB, we talked about the wavelengths. The multi-mode has a broader number of wavelengths that come out. The single mode has fewer, and the DFB is close to what's called a single frequency, or one wavelength of light. So with that, our roadmap, where we've started is the gallium nitride products. And if you see here, we're basically going to increase the technology and capabilities to the market, and so it's going to create greater value. So I just want to go quickly through these boxes. The first one, 405, the violet colors up to blue. With what we've already introduced to the market, we have initial sales, and we're gaining customer interest. We've already started extending the wavelength down into the UV and up toward the green. We showed up at the aquamarine. We have greater form factors than what they can get from other companies in the market. So that has led to increasing interest and more sales. But it's also, when you come back and combine with what we're doing on the distributed feedback, it's these boxes that were enabled us to get something like ME Commons. If we couldn't show we could do that, it wouldn't have worked. And now with the ME Commons coming, we're going to start putting in even more functionality to chips, things called photonic integrated circuits, and we're going to do things called multi-chip modules. And so those higher value offerings are going to move us more up on the value chain, basically establishing us as that sort of a partner of choice for the people that don't want to go to, like, this is what I could get from the other people in the market. So that's basically what our roadmap is. We set out to launch these products at the beginning of the fiscal year, and we were able to do that and entice some of the market, and we demonstrated more than what we set out to do. It's basically what this slide says. And we're continuing to extend that into our next generation. Thanks, Steve. Basically, we're just going to continue to do that while we're bringing in the additional functionality as well. You'll see here that the 4 key verticals that we're doing, because it fits You may notice one's missing, it's display. The biggest reason display is missing is because display is usually a very high volume, low mix, and it's also low ASP and a lot more competition. So we're not trying to go into the white light or into the display type markets as readily, and we're getting more traction in these. So basically we have multiple OEM customers, and they're industries from medical. We have some in the industrial, quantum companies are interested in what we're doing in sampling our parts, and research. We have the, as you know, with ME Commons now we have DARPA and the Department of Defense, and then we also have national institutes. We're qualifying products across these portfolios, and we've got a repeat customer that come back and said we want more, and we're interacting and getting more feedback from customers. So it's validating what, both our strategy and our products. So the custom projects. So I want to talk a little bit. So ME Commons is sort of like a custom project, right? They're coming and saying, we want these things, and there's multiple iterations that we are going to potentially be involved with in ME Commons. But basically, in my career, what I have found, my very first company when I started out of grad school, we had maybe the first quarter I was there, we did about $2 million in revenue. 80 to 90% of that was custom projects. And by the time we went through an IPO and ended up going into a merger, we were about $250 million a quarter. And we were about 10% custom projects. But those custom projects in the beginning were what led to funneling the product. And what it means to investors is it's a way to fund our roadmap that's non-dilutive. So I think it's a win-win for everybody. All right, the patent portfolio. You might notice that some of our patents, we have fewer patents. Basically, we are rationalizing. We're looking at our patents. We're looking at ones that maybe were not as meaningful, the older patents to our new model, and also some of the locations. So you're seeing some movements here. Outlook. All right, a lot of bullets on here, but the concept here is similar. We're going to continue. We have one more company that we're still using as a contract manufacturer for our wafer processing, so we're going to wrap that up. We expect to see some more repeat orders. We're going to continue to invest in the business, both in the capital equipment and so forth, to bring in more functionality, to bring in more commercial-like parts to help us do our jobs. And then we're going to drive that roadmap, demonstrating a wider range of wavelengths and higher value multiple function solutions. So here's a little more on the insourcing. So we acquired the fab, we converted it to a GaN. Later it was an indium phosphide before. We started the operations in July, and then we started to bring the different processes online, which enabled us to do the introductions of lasers in January, and then again in June in Munich. So that all that has happened, we have 4 out of our 5 CMs we've exited. The 5th CM, they're located about 45 minutes from our fab. What we've done with them is we integrated the parts that they actually were using, what do you call it, incubation sites like Stanford and Berkeley. We've integrated those already into our site, and now we're working with them on the final steps that they do in a place called Livermore, California. So what's the bottom line? So basically, takeaway here is there's a huge 25 billion market. And our portion of that, the systems portion, is expected to be 2.5 billion, and it's growing faster than the overall market. It's growing faster for the reasons we talked about. It's consuming the traditional market from some IR lasers, and it's generating new markets in the areas of quantum, defense, biotech. And so it's very exciting there. It's a highly constrained market with all of the other companies we know of are part of big conglomerates. And so they're subject to whatever the bosses want them to do. And we've actually had customers or people from those companies come to us and say, can you grow lasers for us? We can't get enough internal epi support to do our lasers. And we said, well, that's not quite what our model is. So why are we the solution? Well, one, because we are a pure play. We don't have someone say, do LEDs, or now you have to do this wavelength, or those types of things. We are positioned to be a supplier of choice because we have the capability and the know-how to provide flexible form factors and to do multiple wavelengths. We secured orders across those verticals we've already talked about, and we're doing that with MOCVD, and we still have the RPCVD that's kicking in and going to give us a leg up. And so that's basically where we're at today.